In yesterday class we discussed about the classification of solids like crystalline solids and as well as amorphous solids, and today we will discuss especially about the crystalline solids only. Why? Because in entire solid state topic we are only focusing on crystalline solids. We are not discussing anything regarding amorphous solids. So we are discussing about the classification of crystalline solids. Classification of crystalline solids. This is very important even for completed examination also. We have to discuss very carefully. So this classification is done based on type of the constant particle and binding force between the constant particle. Binding force between the constant particles. Okay, what are the two factors we are taking under consideration for classification? Based on type of the constant particle as well as binding force between the constant particles. Okay, based on these categories we have four types. Under that, first of all, I am explaining about the ionic solids. Ionic solids. Okay, you know very well. So in this constant particles is nothing but ions. What is the meaning of ions? Charged particles is calling as ions. Charged particles. Charged particles means what? May positively charged and as well as negatively charged particles. So, it is a ionic solid in which constant particles are ions, then they are calling as a ionic solids. For example, I am taking AB is the ionic solid. In ionic solid, what are the constant particles? A plus and B minus. You know very well they are oppositely charged particles, that's why between them a strong force of attraction will be operating. A strong electrostatic force of attraction. Okay, between ions a strong electrostatic force of attraction means is calling as also like ionic bond. This is important for completed examination. In ionic solid, what are the constant particles? Ions. In case of ionic solids, what is the bond will be operating or what is the attraction will be operating? Ionic bond. Okay, you see some other things here. They are very hard substances and also having high melting point. You know very well, yes, this is a very strong bond. If you want to convert this one into liquid, you have to break this force of attraction that requires more energy. And later we have to see some other things is nothing but if you take ionic solids in solid phase, they are acting as a bad conductors or insulators. Okay, if you take same ionic solid either in a molten phase or liquid phase, they are acting as a good conductors. Yes, students, I think first year we learned under properties of the ionic compound. You see carefully. For example, if you take one of the ionic crystalline solid is NaCl in solid phase, it is acting as a bad conductors. Why? Because here constant particles is nothing but Na plus and Cl minus. But in solid state what happening? They are very tightly packed together because of strong force of attraction. Due to this one what happening? No free momentum of ions. No free movement of ions. There is no momentum of ions. There is no chance to carry energy. That's why they are acting as a bad conductors. But if you take same NaCl only but either in molten or liquid state, what happening? They are acting as a good conductors. Why? If you take either molten or liquid phase, Na plus and Cl minus are very far away from each other. That's why the ions can move freely. So ions can move freely due to free momentum. They can carry the energy from one place to another place. This is the important thing regarding ionic solids. example for the ionic solids. We can write all ionic compounds, we can write like NaCl, KCl, like that cesium chloride, zinc oxide, and as well as zinc sulfide. And we can write one more thing is nothing but we can write these all will be under example for this one is nothing but which one? Ionic solids. You see, very simple. Ionic bond is always formed between metal and non-metal atoms. Yes, check it all these. This is the first category of crystalline solids is nothing but ionic crystalline solids are also calling as ionic solids. Now we are going to second type of these solids or crystalline solids. Second type of crystalline solids is nothing but covalent solids. Yes, what are the constant particle, what are the binding force, everything we will discuss. In case of covalent solids, constant particles are nothing but non-metal atoms. Non-metal atoms. Okay. Due to these covalents is also calling as a network solids. Some other names is also there. Network solids, also calling as a gained molecules or gained solids, or also calling as a atomic solids. Different names for these covalent solids. Okay, you know very well. Okay, if you take for example PQ is the covalent solid. So if you take PQ or the non-metal atom. Between the non-metal atom, what possibility will be there? Sharing of electrons possibility will be there. Sharing of electron means which bond we are getting? Covalent bonds we are getting. Covalent bonds will be there. Okay, that's why it's nothing but constant particles are nothing but non-metal. Between the non-metal, only sharing is a possibility. Due to sharing, which bonds we are getting? Covalent bonds we are getting. And you see some other characteristics of this one. It is nothing but it is also covalent bond is also nothing but a strong bond. Because of strong bond, its melting point will be also high. Its melting point will be also high. And we have to discuss some other things. Is nothing but in all physical states. In all physical states, these covalent solids are acting as a bad conductors or nothing but insulators. Bad conductors or nothing but insulators. But here one exceptional should be mentioned. What the exceptional condition is nothing but graphite. Yes or no? We learned under first year under fourth year group elements. So once you see, even though graphite is the made up of copper atom, non-metal, but according to this theory, it should be bad conductor, but it is a good conductor. So what is the example for this category? Is nothing but diamond, as well as graphite, and we can take silicon carbide. Also came in first year. Is nothing but it's also calling as carborundum, and also nothing but quartz. These all are example for the which type of the covalent solids. So these all important things we begin. Why these are acting as a bad conductors? Why? Because there is no free ions and as well as no free electrons. No free electron, but except graphite. It's an important thing we have to remember, all of you observe carefully. And we have to see third category is nothing but metallic solids. Metallic solids. So you know very well, in case of metallic solids, what are the constant particles? Constant particles are nothing but metals. Yes, I will explain here, see carefully. If you take the metal atom, it is in basically solid phase, having a special nature is nothing but electropositive nature. What it will do, always has a tendency to lose electrons, like n electrons. So now if you can check any metallic solid, in that what will be there? positively charged metal particles is there and mobile electrons will be there. Like this situation in all metal rods. Like this. This is situation in every metal rod. Okay, whatever mobile electrons is there, those only we are calling as sea of electrons. It's like a sea. In that, important particles is nothing but positively charged metals. Those only we are calling as positively charged kernels. Kernel is actually meaning important particles in that matter or in that substance. Okay, now what happened? This is the situation in the every metal rod. Okay, these are highly orderly arranged. That's what we are calling as a solids. That are crystalline solids that are formed by metal. That's what is calling as a metallic solids. Now, between positively charged particles and negatively charged electrons, what happening? Some force of attraction will be operating. That force of attraction only we are calling as which bond? Metallic bond. Yes. So, in case of metallic solid, what are the constant particle? Metals. And what bond is operating? Metallic bond is operating. You know very well they are very hard substances. And due to its hardness, what we can tell? They are having high melting point as well as boiling point. And one more thing we have to discuss, even in solid phase also, even in solid phase or solid state also, they are good conductors. They are good conductors. Yes. Anybody, what the reason for this? If you take even in solid phase also, these metallic solids are good conductors. Why? Because the presence of mobile electron. The mobile electrons moves very freely throughout the substance because small size and lightweight particle easily they carry the energy from one place to another place. Three types is over. What are those? Ionic, covalent and metallic. Okay, now we are discussing about the fourth type of crystalline solids. A little bit important, how to observe carefully. Yes, for the fourth category of crystalline solids is nothing but molecular solids. Molecular solids. I think you will get some idea. Yes, in this, what are the constant particles? Molecules or the constant particles? Molecules or the constant particle. And what is the nature? They are soft. Soft means what? They are or having low melting point will be there. And they are also acting as a bad conductors. What are the things? Constant particles are molecules, they are having soft nature, they are having low melting point, they are almost acting as a bad conductors. Again, important thing here, these molecular solids again will be classified into three categories. Based on factor, it is nothing but types of molecules. Again, based on types of molecules, molecular solids to be classified into three categories. Under this, I will write three simple things or see three different categories. They are nothing but non-polar molecular solids, you know very well. And another one is polar molecular solids. Another one is hydrogen bonded molecular solids. Okay, again based on type of the molecules, they will be classified into non-polar, polar and hydrogen bonded. First of all, we are discussing about the non-polar molecular solids. Non-polar molecular solids. Yes, anybody? What are the constant particle in this case? Non-polar molecules are the constant particle. Molecules only, but non-polar. Non-polar molecules are the constant particles. Okay, can you give some example for the non-polar molecules? They are, first of all, covalent. They should not carry any charge. Means that this non-polarity will be possible due to which one? Equal sharing of electrons. Okay, anybody give some example for this one? It is nothing but solid H2 and solid I2 is important bit. And I will write here one note point. I will write one special category. It is nothing but solid helium and solid argon is also undercomes this category. Is nothing but non-polar molecular solid. Okay, how can you tell, sir, this is the solid H2 and solid I2 will comes under non-polar? Just I will explain you, see carefully. I2 molecule is there. Solid I2 means is made up of so many I2 particles. Yes, if you can take I and I like this. And while close packing, so many I2 molecules are approaching together like this. Okay, you see carefully. Basically, I2 molecule is having any polarity? No. That's why they are calling as a non-polar molecule. But in solid phase, what they are doing? Closely approaching together. While approaching closely together, what happening? Here shaded pair is there. Here also shaded pair is there. They will attract or repel together. Then this pair moves away from this one. This pair moves away from this one. Automatically here we are getting partially positive. Here we are getting partially negative. Here also same situation, partially positive and partially negative. Again what happening? Again pair will be there. It's going away from this one. We are getting here minus, here plus. My question, is it dipole or induced dipoles? Induced dipole. Why? Because while approaching together, newly dipoles is creating. That's why they are calling as induced dipoles. Induced dipole. This is also becoming like induced dipoles. Okay, between them what happening? Yes, if you can see these two molecules, after that positive and negative attract together. This also will reverse this one molecule. Then here also we are getting attraction. What attraction is coming? Induced dipole attraction. Already we learned in first year. It is also calling as London dispersive forces. London dispersive forces. It's a very important thing. In case of non-polar molecular solid, constant particle or non-polar molecule, what type of attraction will be operating? Induced dipole attraction is also calling as London dispersive force. Now we are discussing about the second category. It is nothing but polar molecular solids. Okay, you know very well. So what is the constant particle here? It is nothing but polar molecules. Polar molecules are the constant particle. So can you give some example for polar covalent bond molecules? For example, solid HCl and solid SO2. Yes, you see once HCl molecule is there. H and Cl like this. If you can take one more HCl like this, what happens? It is a partial positive. Why? Because shaded pair is there but going unequally. Why? Because this is the highly electronegative, this is the less electronegative. That's why we are getting here partially negative. Here we are getting partially positive. Here also partially positive and partially negative we are getting. Already having dipole or creating dipole? Already having dipole. That's why these are calling as a polar molecules, means they are considered as a dipoles. Yes, between dipole some attraction is coming. That is only calling as dipole attractions will be there. Same situation will be happening even in SO2 molecule also. That's why they are calling as a polar molecular solids. And third under this molecular is nothing but hydrogen bonded molecular solids. Yes, you see carefully, hydrogen bonded molecular solids means what is the special here? If you take constant particle, they are also made up of polar molecules and having a capacity to form hydrogen bond. Yes, so many best examples we have, we will discuss. Here also constant particles is polar molecules only, but what is the special here? They can having an attraction or they can have a capacity to form hydrogen bond. Best example for this is nothing but ice. And we can take one more is nothing but solid NH3, solid ammonium. Yes, just you see, ice is, I am explaining that one. You see, ice is made up of water molecules. Yes, you take water molecule like this. Okay, basically it is a polar molecule. Why? Because unequal shading is going on here. We are getting partially negative, here we are getting partially positive. It's a one water molecule. Okay, ice means close packing of H2O molecule. Then one more water is approaching here like this. Then also we are getting partially positive here, partially negative. This is another water molecule. Ice means they are very closely packed together. Then something is happening between them. What is that one? One of the molecule of positively charged hydrogen atom having attraction with another molecule of highly electronegative element, nothing but oxygen. Such attraction only we are calling as which bond? Hydrogen bond. Is there any such chance here? No. That's why just they are calling as a polar. Even though they are polar and having extra capacity hydrogen bonding, that's why they are specially calling as a hydrogen bonding. Okay, now I will ask you one question. Dry ice is there. Dry ice is undercomes which category? Is also will land in fourth group element. Dry ice means is nothing but solid CO2. Yes. Is it ionica, covalent, metallic, molecular? If it is molecular means which category? Let's check it here. Anyway, solid phase. Is it molecular? Atom. Molecule. The spark it is undercomes directly fourth category. First of all, it is the molecular crystalline solid. Okay, after that again polar or non-polar or hydrogen bonded. Check it once. Yes, you study the CO2 molecule once. In CO2 molecule, what will be there? Yes, linear shape having by this one. Yes, like this. Okay, between C and O, a bond is there that will be having polarity. That polarity or dipole moment towards which side? Highly electronegative element oxygen. Same situation here also towards oxygen atom will be coming. This dipole moment is mu. This dipole moment will be also mu, but in opposite direction. That's why what happening? This positive and negative value mutually cancel together. The net momentum will be zero. If net momentum will be zero, then it is calling as non-polar molecular solid. This is the very best example. And so many times you ask in exams also. All of you got clarity regarding this one? Yes. So what we discussed just now? The classification of the crystalline solids. Now we are going to discuss about now we will discuss a very important topic furtherly. The basics and very important here is nothing but crystal lattice. Crystal lattice, also calling as a space lattice. Space lattice. 2-3 definitions will come. You have to practice and understand very carefully. What is this one? Crystal lattice or space lattice. First, I will write the definition. You see carefully. The three-dimensional arrangement. The three-dimensional orderly arrangement. Orderly arrangement of constant particles in space. Got any idea? See, the crystal lattice is also calling as a space lattice, means the three-dimensional orderly arrangement of constant particles in the space. For example, imagine this area. In this area, one crystal is existing. How, for example, like a cubic shape. Yes, like this will be there. Okay, now what is happening in the space? It is existing like a cubic shape. In that cubic shape, the constant particles are located at corners of the cubic shape. So, such kind of three-dimensional space only we are calling as a which one? Crystal lattice or space lattice. Just I will show you one example. Okay, this is like a cubic shape will be there. Okay, now this is one type of the crystal, whatever it is, let it be. So now what happening? It is resultant having a cubic shape. So this cubic shape is formed by arrangement of the constant particle where? Corners. So this type of the three-dimensional arrangement of the constant, that too in a proper order only we are calling as space lattice, or also calling as a crystal lattice. Okay, now we are discussing one more point, is nothing but lattice points. Also calling as lattice sites. Lattice sites. These all are important for competitive point of view. Understand very carefully. What is the meaning of lattice points or lattice sites? It is nothing but relative positions. Relative positions of constant particles in crystal. What is the meaning of relative positions of the constant particles in the crystal? Yes, this is the crystal. Here, the total crystal is occupied by that one? No, some special positions will be there. What are the special positions? Only corners. How many are there? 8. So those only we are calling as, in this crystal, 8 lattice points or sides will be there. Are you getting that? So what is the meaning of lattice points? Relative positions of the constant particles in the crystal. Okay. In this crystal, for example, cubic, only constant particles are located at corners. How many are there? 8. So relative positions only we are calling as lattice points or sides. Okay, now we will see one more definition is nothing but unit cell. Yes, very important. What is the meaning of unit cell? Unit cell means a smallest part of the crystal. Smallest part of crystal which is repeated three-dimensionally, which is repeated three-dimensionally and having shape as like crystal lattice. Once you see carefully. So what is that one? Smallest part of the crystal which is repeated three-dimensionally and having same shape as like crystal lattice is